to record the session, and I need to turn my writer on. In other words, what slope is really, it's the difference in the y's over the difference in the x's. But you got to make sure you go in the same direction. Well, to me, it's easier to subtract 6 minus a minus 4. So that is plus 10. And then minus 10, I got to go in the same direction, minus a minus 7. What's that?
-3. So it's 10 over -3.
There's our slope. What's the slope of QR?
It's 10 over -3.
There you go. We're done with that one. What? Number 6?
Number 7.
Number 7. Okay. Scroll down. Can't scroll down much, but I probably don't need to. Given RSTU is a square, VR is congruent to SW, is VWTU an isosceles trapezoid? Definition of a trapezoid?
The base are parallel. The bases are parallel.
Two sides, yeah. Then, well, it's whatever you call a base. I mean, I can draw a trapezoid like this also, and that's a trapezoid. What it is two opposite sides have to be parallel. That's it. That's the only definition I know of, and it's four-sided. So the question is, what's the definition of an isosceles trapezoid?
It's where the other two sides are equal or congruent.
Okay. Are they here?
V, W, T, U. Yes.
In other words, these two sides are what needs to be equal. And they're equal why?
Because I'm not sure.
Well, let's figure out. We have to prove it. You know, every one of these is not just getting the right answer, I guess, or not. Do you always have to prove them? Or I guess this could be a question on the test. But let's try to prove it. Just because it's a fairly simple one to prove. How are we going to prove those two are equal? Usually we have to prove the triangles are congruent, right?
And we already have two sides, so we need to...
Sides and an angle. We got that right angle, and we got that. So we got side, angle, side. That proves congruency. That makes VU equal to TW. Excuse me. Is triangle VWX an isosceles triangle?
If the triangles on the bottom are congruent and the square is a square, then it should be an isosceles trapezoid because VX...
Hold on, we're looking for an isosceles triangle for this shape. Okay, so let's go through it again. Why is that isosceles?
Because VX equals WX.
Why?
Because addition property with TW and TX.
We don't know that TX is equal to XU. Here's why. You had it. When you said these two triangles were congruent, that means that angle is equal to this angle. And those are the two base angles of the big triangle. So if those two base angles are equal to one another, then the sides have to be equal.
Oh, yeah, because of,
Well, that's the definition of isosceles triangle. It's not just two equal sides. It's two equal sides and their opposite angles are equal. So if you find a triangle whose opposite angles are equal, that means it's isosceles. Now is part C. I assume they're talking about that triangle. Is that isosceles?
I know that ux is equal to tx because
of that addition,
yeah.
subtraction. Yeah, it's going to actually be subtraction because we know this is equal to this, and we know that's equal to that, and therefore that's going to be equal to that. So that makes it isosceles. So yes, yes, and yes.
Yep.
Okay, what next? Next page?
Number 8.
Number 8, okay. In parallelogram ABCD, the ratio of AB, here let's draw it. Ratio of AB to BC is 5 to 3. If the perimeter of the thing is 32, find what AB is. Now, what mistake did I just make there by labeling that 5 and 3? That's not its distance. It's the ratio. So I should have labeled it 5x and 3x. And now it's in the ratio, and it can be any number, any multiple of 5, as long as it's the multiple of 3 also. Okay? So that's the first thing we need to do. Now what?
It'd be 3x plus 5x plus 3x plus 5x equals 32. So it'd be 10x.
16x.
6, yeah. So x equals 2.
So what's AB equal to?
AB is equal to 10.
And that's 6. Okay. So the trick really on those kind of problems is adding that variable. Which one? 9?
Number 9, yeah.
Okay, that big thing, it looks like a parallelogram, is JM is a diagonal which bisects both of those angles. OJ is equal to x plus 5. KM is equal to y minus 3. And JK is equal to 2x minus 4. Solve for x.
Okay. So x plus 5 equals y minus 3.
Okay, that's one equation and two unknowns. Probably need another equation.
And then 2x minus 4. Once we find what one of them is equal to. So x.
Well, hold on a second. 2x minus 4 what?
Minus 4.
Yeah, but that's just an expression. That's not an equation. And notice that we haven't yet used some of the information they gave us.
The angles.
Yeah, they're bisected, meaning that one's equal to that one, and this one is equal to this one. So what are those two triangles?
Not isosceles.
No, they're congruent.
Yes.
In other words, triangle 1 is congruent to triangle 2 based on which theorem?
Angle, side angle.
Yeah, because that's common to both. So it's the two end angles and the two sides. So the fact that we know those two triangles are congruent means what?
That all the parts will be congruent.
Well, what equation does it allow me to write? Now I'm confused. Let's see. Let me make sure. Whenever I get confused, I go back and reread it, because usually the mistake I made is I've not read it correctly. So far, it looks like I've read it correctly. I've used 2, and I really only need to use 1. I think that's going to help us. In other words, those angles, I think, have to be the same as the ones at the top left. Because we know that opposite angles of a parallelogram are equal. So if angle J is equal to angle M, well, then each of these smaller ones is equal. Now, if we examine these triangles, whether it's 1 or 2, let's look at triangle number 1. The fact that those two angles are equal means what? What kind of triangle is it if it's got two equal angles?
Two equal angles?
That makes it isosceles.
Isosceles.
Yeah. So the two opposite sides to those angles have to be equal. So the other equation I can write is that 2x minus 4 has to also equal y minus 3. In other words, that side has to equal that side. Even though they've drawn it not to scale, they've drawn it in an attempt to fool us so that we won't see all of that. But now that I have 2, it's the best way to solve those two equations.
Just find what 1 is equal to and then substitute it.
Actually, there's an easier way. They're both equal
you
to
can
y
get rid of the
minus
1.
3, right?
Well,
I mean, if you've got this entity equal to y minus 3, and you have this entity equal to y minus 3, well, what can you say about those two expressions?
That they're equal.
And that's what I'm going to write. Now I have one equation, one unknown. Make that x equal 9. So we solve for x. It's going to be relatively easy to solve for y using any of those equations. And then finding the perimeter will be a piece of cake also, because this side over here is also 2x minus 4.
Okay.
So the whole key to this problem really was figuring out that that angle is equal to that angle, because it sure doesn't look like it the way they've drawn it. So the only way you can really figure that out is by going back and carefully figuring out what that means.
Mm-hmm.
It means it's a rhombus that we've just dissected. It's not just a parallelogram, it's 4 equal sides also.
Mm-hmm.
What's the next one?
Number 10.
Okay. How many different angles do we have in a parallelogram?
4.
How many different angles do we have?
Oh, 2.
2. What should we call them?
X and Y?
Yeah, why not? X. And I can make this a 2-variable problem, but what else could I call this one up here in the upper left?
The upper left? Oh, yeah, 180 minus X.
Which leaves it as a 1-variable problem, which is going to make it simpler. Okay? In other words, there's a lot of 2-variable problems, word problems, that can be made 1-variable word problems just by knowing that those 2 angles are supplementary.
Mm-hmm.
Okay, now what can I say? Now that I got my angles defined, the measure of one angle is 40 more than 3 times the other. Well, the way I've drawn it, which angle is that going to be?
That's going to be the X.
Now, I've made that the biggest angle, the way I've drawn it. Okay? And since one angle is 40 more than 3 times the other, that's got to be the biggest angle.
Yeah.
Okay? Now, you're right. You could solve it just the same using X, but I think it makes more sense with my diagram to say 180 minus X is equal to what?
Is equal to 30x plus 40, or 3x plus 40.
Yeah. And again, if you solve that, you get 4x equals 140, x equal 35. So our 2 angles are 35 and 145. Now, is that 40 more than 3 times that? Yeah, that's 105 plus 40, 145.
Mm-hmm.
So we solved it and checked it. Now, just out of curiosity, I won't belabor this point, but we don't have to do it the way I drew it. I could say X is the big angle.
Mm-hmm.
So I could say X is equal to 3 times 180 minus X plus 40. In other words, you don't have to always draw diagrams. There's nothing. Would have given me the same answer for the 2 angles. It's just that X would have come out to be 145.
Mm-hmm.
Okay? So, what next?
Number 11.
Okay. I think I can scroll up a little bit here. Just a little.
It only goes to D.
Just a little bit. Oh, that's all you have today?
No, then I have 17, but that's on another piece.
Oh, another page. Okay.
Yeah.
Answer always, sometimes, or never. Okay. A quadrilateral is a parallelogram if. Well, let's start with A. Diagonals are congruent.
That is always true, right?
Well, how can we determine that? Can I draw a parallelogram whose diagonals are not congruent? Yeah, I just did.
Oh, yeah, you can, a rhombus.
Well, that's not a rhombus, but I've made this end a lot closer to this end than I have this end to that end. it's a parallelogram. It would have to be a rhombus for them to be congruent. It's like that is a rhombus. But the way you look at it, the way they've drawn it, if I make that, those two are not equal. It's only if it's a rhombus that they are. So what is the answer? In other words, if it's a rhombus, they are congruent. If it's not a rhombus, they are not congruent.
So it's sometimes true.
Yeah. One pair of opposite sides are congruent, and one pair of opposite sides are parallel.
That is sometimes true.
Okay, a quadrilateral is a parallelogram if one pair of opposite sides are congruent. And do they mean the other pair?
Yeah.
Because they really should have said that. Because I got a trapezoid. I've got one pair of opposite sides are congruent, and one pair of opposite sides are parallel. That's not a parallelogram. So what is it? Is it always, sometimes, or never? Because I certainly can draw that where those are parallel and the other is congruent. Also happens to be parallel, but but it doesn't have to be.
So it can be sometimes.
I think it's sometimes, because that's this figure right here. One pair of opposite sides are congruent. It's an isosceles trapezoid. And one pair are parallel. So that's not a quadrilateral, so it certainly isn't always. And since I can draw it, it's not never. So it has to be, if it's not always or not never, excuse me, not always or not ever, then not never. Actually, you know what? That is what I want to say, isn't it? That sounds like horrible grammar, but that's exactly what I meant. If it is not always, and if it is not never, then it has to be sometimes.
It just sounds weird when you say it.
It sounds weird. It sounds like you should say if it's not always and not ever, then it's sometimes. But ever isn't the choice. We don't have ever as a choice. That's kind of funny. That's weird. C. Each pair of consecutive angles are supplementary. Well, we certainly know that if I draw a normal parallelogram, 1 is supplementary to 2, 2 is supplementary to 3, 3 is supplementary to 4. Now, can I draw a figure that is true, and yet it's not a parallelogram? Can you? Let's start off with a flat line, okay? Now, if I make a line like that, and I insist that 1 be supplementary to 2, that makes that parallel to this. Based on parallel lines and adjacent angles. And now, if I do the same thing up here, and I make that so that it's 2 is supplementary to 3, then that makes that parallel to that, and you have yourself a parallelogram. I don't think you can have two opposite sides be parallel and have it not be a parallelogram. I think that one implies the other, and the other implies the one.
Mm-hmm.
Okay, all angles are right angles.
That is always true.
Yeah, it is. Just like, so we had two S's and two A's. I believe, yeah. Last two were both A. Whoops. You said 17. Okay.
Yeah, that's the last one.
Okay. Notice what this is. My M problem.
Oh yeah, so yeah.
Okay, so let's make it a pure M. Like, hold on. In other words, yeah, you want to be able to do this the hard way, but it's always nice to recognize when you're looking at an M.
Mm-hmm.
There's my M. What's this angle right here?
90, I think.
If it's on the other side of that 90-degree angle, it's 90.
Mm-hmm.
So what's my X equal to?
90 plus 55.
Yep. It's an easy way to do it. Just to make sure you know how to do it the hard way, what would be my next step?
You could do 180.
Well, there's a number of things you can do. Since they've given us a limited amount of space here, I presume they don't want us to extend that line and extend that line. And there's an easier way to do it. The easier way to do it is just to extend that line. Now, what's this angle? Well, actually, what's this angle? 1. In other words, this has to be a right triangle.
So that'd be 90 plus 55.
90 minus 55. Oh, you're saying this?
Yeah.
Nah, just figure out number 1 first.
Okay, so it's 35 degrees.
Okay, and now X is what?
145.
Okay. I feel safer with that. Oh, okay. You were treating it as an exterior angle, and you were using the exterior angle theorem, which says X is equal to the sum of the other two angles that it is not a linear pair with.
Mm-hmm.
And that's 90 plus 55. And that is also the shortcut way to do that.
Mm-hmm.
So that's a good one to know. All those little tricks will save you seconds when you go to take your SAT or ACT test. It's knowing little things like that that can really speed up the solution of a problem.
Mm-hmm.
Okay? Is that going to do it for you tonight?
Yeah, that's all I had.
Sounds good. You're doing great.
Mm-hmm.
Talk to you next time.
Yep, thank you.
Bye-bye.